All right, friends. Good morning, good afternoon, good evening, depending on where you have joined from. The last session for the EMEA edition is Azure Synapse Analytics Serverless SQL Pool. Wow, what an overloaded term. Um, and the speaker for the session is Armando Lacerda, and great to host Armando once again. So, yeah, we bring you a world renowned expert in Armando. Armando, over to you. Thanks for joining us.
Hey, thanks for having me. All right, so yeah, as I was saying, certifications, some of my certifications in here, they are something I do for fun, and I highly recommend you guys in the audience to consider going to some certification because you learn a lot about everything that's around the technology when you start studying for a certification. So the benefit of the certification is not really the certification, but what you learn on the way to get ready, right, to prep for the exam. Our agenda here today is all about Synapse and specifically about a particular offering, a particular data engine that exists inside Synapse service, right? Synapse Analytics, which is the serverless SQL pool. We're going to go over some of these details again and understand what we're talking about. But one of the things we need to get out of the bat right from the beginning is to understand that Synapse is is a service comprised by multiple components, which also means it's a service comprised by multiple data engines. So we have multiple options to work with data inside Synapse, and whatever flavor you feel more comfortable doing with, or your team feels more comfortable working with. So yeah, we're gonna go over an overview of the Synapse architecture, and we're gonna briefly discuss this concept that's out there called the lake house, the data lake house, which is kind of an interesting one. It was being coined for a couple of years, and it tends, I feel it's gonna pick up a lot of steam, and people will go into that direction super fast. And then we're going to zoom in inside serverless itself, which is an offering inside Synapse, like I mentioned, and jump into the demos. If you have questions as we move along, I highly recommend you to send your questions through the chat window. And it's going to help us out with the questions at the end. So I really hope you guys are going to interact with me as we go along the questions. In this particular slide, what we have here is the release of Microsoft Azure Synapse Analytics back in 2019. So before Synapse, what we had was this thing called this guy here, right? The Azure SQL Data Warehouse. It's so long ago, I'm even forgetting the name. It was the Azure SQL Data Warehouse. So the Azure SQL Data Warehouse, this guy here at the very beginning here, it was an evolution as a natural sequence of the Microsoft platform for BI. So that was the BI offering up in the cloud. And the whole thing about BI, as we know, is creating a database, is creating that huge database for containing, holding or hosting all your data inside that database. And you bring the data in, you do ETL to get the data in, or ELT, whatever you do, to get the data in, and you store the data there inside that database. So data is moving and moving volumes everywhere, from everywhere inside your data warehouse. And Microsoft started this vision of what Synapse would be. Like Wolfgang mentioned, it was the very first person I have seen mention the meaning of the word synapse that came from the physicians, right? The medicine, the anatomy of a human body, which is the connection in between neurons, which means sending information from point to point, right? And as we send information, process information, we learn. But that's the idea. We have multiple points of sending information, and the data warehouse was just one of those points, one of those neurons. So Synapse, the idea of Synapse is to collect and connect everything together in order for us to process data or have a full platform to implement data transformations, data pipelines. And what we end up with is something like this. Let me get myself smaller here. No, I was twice there. No, just me. What we have is something like this, right? We have a full data platform of data coming from all the way there on the right side collecting data from IoT devices and IoT systems through message bus services like Event Hub. So all this data flowing through, usually landing on a data lake. And that's the big point in here, right? To make sure I understand that this data, because of the speed and the volume the data arrives, usually want to get them on a place where we're going to have very little latency to store that data. So no extra layers of processing or filtering or validation. We just accept that data. And once the data comes from these sources, even data factory from Microsoft platform, right? When we do Azure, we have this low code or no code platform to process data called Azure Data Factory. And then in the lake, we start mowing the data, right? We start processing the data, chewing the data, and getting the data cleansed and better organized, formatting it or getting in agreement with some sort of modeling and organization. And then we get the data ready for consumption. So with Synapse being at the beginning just a replacement for Azure SQL Data Warehouse, it was never the design, but at the very beginning, the only thing that was really GA or available to use in production was that replacement. So it fit like this, right? It just interact with other services that were already there. But Synapse was supposed to be, from the beginning, like I said, way more than that. So when we blow up and go into the Synapse service itself, and my slide doesn't want to advance, so let's see if it goes now. Yeah. When we go inside Synapse itself, the blow up inside Synapse, what we're seeing there is actually 3 data engines. And it's very important to understand that you have 3 data engines because they will behave in different way and they will interact with data in a different way and even store data in different ways within the same service, right? Built into the same service. So that Azure SQL Data Warehouse that we have seen before, that was there before Synapse, is actually that guy there on the far right, which is now called the dedicated SQL pool. And the idea of the dedicated SQL pool is your traditional BI approach. So what you do in a dedicated SQL pool is collect your data from your sources and whatever external sources you have. Again, the data lake is one of them, but you could have multiple other ones, and bring that data into or inside the dedicated SQL pool storage. The dedicated SQL pool has both compute and storage, sort of a disconnected way within itself, so we can grow compute up and down without changing storage. So the volume of data storage is not tied up with the compute. If you have seen, if you have been working with Azure for a while, and if you have touched Azure SQL Database, the regular SQL Server offering in Azure, most of the options there, they tied up the amount of data you can store with the amount of compute you come to sign up for, right? To subscribe for. And Synapse dedicated SQL pool, we don't have that relationship. You can have hundreds of terabytes or petabytes of data and one simple node, one single node holding that data, process that data. It's going to take forever to go over the data, but you could, in order to save costs, for instance, or just dealing with regular very simple queries when you're not really crunching data around. So there, it's very disconnected. And that was the Azure SQL Data Warehouse. It's exactly the same thing here. The point I want to drive in this one is in the dedicated SQL pool, your tendency in there, what you usually want to do in order to have the best outcome and best utilization of the service is to bring the data into the dedicated SQL pool storage, which is called the distributions. And that's data movement. You're moving data around. That can slow down your things while you're moving the data, right? Once the data is there, it's fine. The dedicated SQL pool can work with the data on external sources, straight from external sources like the data lake, but it relies on external processes like Polybase, right? It really depends on some external elements. It prefers to work with data into the distributions. So to get the data there, you get the pipelines. Again, the pipelines is the parallel of what Azure Data Factory is. The idea is to create an environment that's a graphic user interface environment where you do very little code or no code. And what happens under the hood is whatever you do in the pipeline is actually translated into Spark jobs, right? There will be Spark, whatever tasks you come to create, whatever come to set up, it will be translated to Spark tasks, Spark scripts, and those will run under the hood without you seeing the actual Spark code, unless if you create yours, and it will be executed for you. So it's a way to make it, faster, like integration, SQL Server integration service used to be. Under the hood is C#, is .NET, not C#, it's .NET framework, and there was a graphic user interface on top of it that you could do very little code or no code at all, right? So that was kind of the premises, that is actually kind of premise of the pipeline, so you can get the data across and transformed. And of course, you have the Apache Spark from Microsoft. And here's a very important thing here to understand, right? If you're not that familiar with the platform, Apache Spark is open source. There are, over 100 implementations of Apache Spark from multiple data warehouses out there. The most famous one nowadays is Databricks. In my opinion, is one of the best ones out there, with a lot of perks and benefits and some proprietary stuff in there. Although it's based or built on top of open source, and it has some proprietary stuff in there. It's an awesome platform. It's been leveraged everywhere. So Microsoft has a competing product inside Synapse, which is the Apache Spark Pool. So it kind of does, based on the same open source, also has some proprietary elements and some differences, right? Like in the Apache Spark Pool, it's already built into the environment, the .NET support, while in Databricks, you don't have it. So if you would like to use some .NET libraries to do your data transformations in there, it's already there in the Spark Pool. So just the difference of two environments based on the same open source project. But what we're looking at into this session here is the fourth one that's not showing there, is going to show now, which is the Serverless SQL Pool. And the funny thing about the Serverless SQL Pool that kind of entertains me is that most people don't know much about it. It's there. I have been to clients. I work as a consultant for a company called Wintellect here in the US. They're based out there in Georgia, in Atlanta. I'm here in California, so I've been working remote, not just because of COVID, but also because the company is really remote. Most people don't go to the office, which is super cool. But the point here is, as a consultant, we go into customers and we see customers leveraging Synapse. And because dedicated SQL Pool was the first one coming GA from the release back in 2019, very little people have been, or very little, not that many companies have explored the Serverless SQL Pool. And the Serverless SQL Pool changes the approach from the dedicated SQL Pool, in a sense that it does not require you to move data into the engine storage service, because it doesn't have one. That's the funny thing about it. The Serverless SQL Pool is serverless in the sense that we don't have to worry about scaling up and down services. For instance, in the dedicated SQL Pool, we have to take care of our DWUs. If you go up, if they go, your DWs, I rather say, if they go up and down, you need to manage those things and resources and the costs, because your cost is based mostly on the computing power you give it to the dedicated SQL Pool. But in the Serverless SQL Pool, we don't have any of that because it's serverless. But besides being serverless, it's also storageless. That's very funny, right? Because you have a database service. It's supposed to be for data warehousing and big data, a large amount of data, but you don't have a storage or a dedicated storage to it, because it's fully reliant on the data lake. So the Serverless SQL Pool, it's actually just a compute service, like Spark is just a compute service that doesn't hold data in itself. Well, it does, but it's just metadata. It's not your data in your tables. It's just the metadata, like table structures and things like that. So it's just about metadata. It doesn't hold the actual data, and it completely depends on and leverage on builds on top of the data lake service, the Azure data lake service, specifically the data lake service Gen 2. You can work with blob storage, but we lose a lot of flexibility and performance when you do blob storage. So more likely you're going to use the data lake Gen 2. And this is what Synapse is today, right? These four engines we have there. Again, pipeline is kind of a GUI on top of Apache Spark. So we have these three data engines: the dedicated SQL pool, the Spark SQL pool, and the serverless SQL pool. This is what we see inside Synapse, along some other elements, right? We have the data lake, like it's part of the workspace as well. The workspace is an element of the Synapse environment. So just speaking about the data engines, this is what you have, right? And like I said, you have an awesome collection of options to get the data process as fast as you want, as easy as you want, or as specific and elaborate as you want. So the architecture goes like this. It was there before. The approach was like that. You had data factory outside Synapse because it was GA before. And now, and by the way, the Azure Data Factory does the same thing that pipelines does, as Synapse pipelines do. But the difference in here is the Azure Data Factory is like that GUI thing on top of Databricks. So what works under the hood in Data Factory is Databricks, while in Synapse, what works under the hood of pipelines is Microsoft implemented Spark's deployment, right? Spark engine. So they look the same, they feel the same, but they're not the same. So it's not that easy to get things across. If I do something in Data Factory to get that into the Synapse Analytics, I may get into some bumps and not to get the thing to work. So the architecture was like that, like I shown before. Now Synapse wants to offer you an environment that will not be really that dependent on Databricks if you don't need specifics of Databricks, and Data Factory as well. So it becomes something like this. The idea is you keep flowing your data into the data lake, and if you want to create a BI solution where you bring the data into the dedicated SQL pool, you do have that option still. Let me see if this thing is working now. It's kind of sluggish a little. Yeah, but there we go, right? So we have the dedicated SQL pool. Yeah, my clicker is not working. It's very sluggish, very interesting. So you have the dedicated SQL pool. So this implies you're moving data or copying data from the data lake into the serverless SQL pool. So data is flowing from here to here. Or you can rely on the serverless SQL pool, which relies on the data on the lake. The data stays in the lake. And any client application can deal with or interact with any of these two engines because they both speak SQL, right? They're all T-SQL. They both use TDS protocol. So any application you want to use, the application you're already using, I'd rather say to collect data from the dedicated SQL pool, for instance, should work out of the bat straightforward with serverless SQL pool. So that's the benefit of the SQL pool. We don't have that much data movement if you don't want to, and you can still work on Apache approaches like bronze, silver, and gold when processing your data in the lake, and then query your data from the lake. And that brings us to this concept that has been becoming more and more popular, which is the idea of the lake house. So we used to have two competing ideas, right? Two competing approaches. I can create either big data, or I can create a data warehouse. And the idea of the big data is, streamlining data, batch processing, or streaming process. And I keep processing the data until it's ready for analysis. And once it's there, it just stays there, right? It's like a copy of the data ready to process. I may come and reprocess the thing, refresh the thing, but there is no actually transactions going on there, right? It's just pushing and refreshing data. That's usually what people do there in the big data. While in the BI approach, we do have, for most engines there, we do have that idea of transaction support, the asset, right? Atomicity, consistency, and things like that. All the four letters on the asset acronym. So the four concepts on the asset acronym. So the idea of the the data lake house is, could we have this BI behavior of transactions and consistency and all of that, and absurds and all those transfer, all those data changes tracking working in the lake. So that concept, like I said, it was coined a couple years ago, and this is a very popular diagram or illustration that comes from the Databricks team, and the link is there on the slide deck. I still have to publish this slide deck to the website, so I'm gonna do that later. But the link is there if you want to take a look on the actual blog talking about the concept of the data lake house. Here you kind of see an evolution. You see out there on the right side, you see the data warehouse approach, and you have the operation databases doing the ETL like through the pipelines and creating they call the unique source of truth, right? Your point of source of truth on your data warehouse, and from there you split up your data marts for performance and data isolation and security, whatever you want to do in there. Then we come to the lake, where we work with big data, and once again you have your ETL working with the data on the lake, right in the middle column there. Work with the data and process the data, get the data ready for consumption. And like I mentioned before on the Azure Data Warehouse approach, from those ETLs and data processing, you still populate your relational database engines with the data coming from the lake. So a lot of data movement from the lake into there, and the lake gets in there just to be for the sense that it's being faster and more expansible, extendable than the regular storage on the warehouses. And now we have this idea of the lake house, where you're noticing there that the absence in there is the the real-time database, right? The data marts in the database, they're gone. So where is the data? Well, the data never leaves the lake. The data stays in the lake. And the serverless SQL pool offering Synapse is exactly for this case. Like I said, it doesn't store data inside in itself, right? It completely depends on and works with the data that's already in the lake. At this point where we are in the technology, right, in the serverless SQL pool, it's not yet a service and offering to do data transformations. We do have support to do what they call an operation that's called CTAS, C-E-T-A-S, CTAS. So create external tables. And the name here, external, is key because we're talking about tables that exist in the lake, not on an internal storage. So that's what they call external. Every time you see this external naming there, they refer to something that exists in the lake. So create an external table as select. So if you're familiar with SQL Server, I believe you are, right? This is a symposium about SQL Server. It's kind of the select into when you create a table based on the result of a select. Is the same idea in here. So the kind of transformations we can do in serverless SQL pool today in scale, right, based on the lake, is creating new tables based on data that's already there. So it's a very, a very limited approach to data transformations at this point. It's really focused on extracting the data and serving data to other layers, that data that's already in the SQL pool, in the data lake. So the data in the data lake is being transformed either by Spark or pipelines, or Databricks if you want to go outside the box, outside the Synapse box, or something else you are doing in the lake, whatever you do that in the lake, right? And so Synapse Serverless SQL Pool lines up pretty well with the idea of the lake house. Not into the asset aspect of it yet. So that's kind of a shocking for most people when I mention this. In the serverless SQL pool today, you don't have inserts, updates, and deletes. So those are not supported yet. SQL Server is under the hood. So these things are just disabled. I don't know. I have a feeling that these people from Microsoft, they may be working on get these things running at some point in time, but there is no news or announcements around that. It's just my feeling. SQL Server is there. Just turn it on, please. But at some point, I believe it will be there. At the moment, what we have is this service to collect the data. So this is what we have, right? Our elements in here, and I'm going to use here my pen, and hopefully the pen will work. For some reason, my laptop is kind of sluggish today, so I apologize for that. So what we have here, the central element is the lake. Yeah, it took a little while, but it's there. Is the lake. And what we have is any kind of processing elements we want to associate with the lake to do all kinds of data transformations. And this was supposed to be an arrow. This thing is so sluggish that my handwriting is already bad, it's even worse. So whatever you need to do in the lake to process the data, we are free to use any tool from any software vendor, because the lake is the lake, right? The lake is just a file system, super fast, right? We have like I think it's 2 terabytes per second, right? We can traffic in the lake in Azure today. So it's super fast. It is awesome technology under the lake thing. But the point is, we can use any processing, any computing resource we want to use on top of the lake, as long as it keeps writing the data into the lake. And when I get the data ready in there, when I go into end user applications that need to work with that data, most applications out there, they have trouble communicating, for instance, with Databricks and Spark pools. Because if I need Databricks to supply data to Power BI, so in Power BI today, we do have a connector to query data from the lake through Databricks. That is a Databricks connector in there. That will require to have the Databricks cluster running 24/7, at least in the business hours when people potentially could come and request data from the lake. Or if I have published my data set in Power BI and I have reports on it and is refreshing on schedule, whatever schedule that is, that Databricks cluster must be ready there for Power BI to be able to refresh the data. And when you put it, if it's not there, if you have to warm up the cluster, it may take a little while to get the cluster up and all the mambo jumbo that goes around getting the cluster ready to answer queries, right? To answer requests. So those things are possible. Connecting these two guys here is something that's really possible. But it's something I try to avoid, right? I don't like that particular route. What I usually do, and that's why I put this session together, is to get serverless connecting these guys, right? Getting Power BI, querying the lake, tapping the lake through serverless SQL pool, because it gives me an interface that's very familiar to Power BI and to people, which is the regular SQL statement, or most of it. And the most important thing is I don't have to put a cluster up. One of the best things about the serverless SQL pool is it charges you by the data volume it processes. And it's very important to keep that in mind. It's by the data volume it processes. It's not by the data volume you retrieve. So like if you have 1 terabyte of data, you run a query and you collect 100 megabytes, you're going to be processed by 100 terabytes of data you tapped into, right? And how much does it charge? It's about 5 cents per terabyte that's being processed. And it's not that expensive, especially if, it depends on your pocket, right? On your budget. So I should not say it's not that expensive, but in comparison with other tools, and depending on how often you tap the database, this can be a very viable approach to query the data, especially because it doesn't require any setup. I don't have to set up a cluster. I don't have to put up a cluster. I just I'm going to demo that in a bit. I just hit the database, and it will reply to me. Sometimes when you hit for the first time, the performance can be a little slower on the first hit because it has to warm up some stuff, some elements inside. But again, it's not that dramatic, right? It's not like 2 minutes, 3 minutes to get things running. And we're going to see that in there. So that's the approach of the serverless SQL pool, right? To be that interface in between. And this is the last slide of this presentation. I'm going to jump into the demo right after that. I just want to give you like an X-ray vision of what happens when you use your like Power BI that's in there when you use a client tool and you hit serverless SQL pool requesting for data that exists in the lake. So you don't see this much, this architecture being much, you know, explained or documented in there. There is nothing actually in the Microsoft documentation, docs.microsoft.com. There is a recording of a session that was given back in 2019 when Synapse came out at Microsoft Ignite in Orlando. It's a 30-minute session they're having there with the product team. They kind of they dive deep into what I'm about to explain here. In like 10 minutes, they spend 30 minutes doing that. And there is also some white papers around. So if you want to, I would like to invite you to connect with me on LinkedIn, and I can, you know, we can exchange some information in there. I can give you some tips, some links, and things like that. I love to get people connected with LinkedIn. I learn a lot from people asking questions after sessions through LinkedIn. It's my preferred platform. You know, Facebook is more for my, you know, my personal things, and I don't tweet much, but I'm also in Twitter. But back in here. When you use a client application, let's say you're using Power BI, like I'm going to do in the demo, and you're going to tap into Synapse Serverless SQL Pool. What happens when you do that? Some of you who have been working with Azure SQL Data Warehouse and Synapse dedicated SQL pools, you're going to see something that sounds familiar at first, but it gets different, a little different when it progresses. So when you send the query, what happens in there is that front end, which is the serverless SQL pool. That front end gets your query, you know, breaks down your query, starts to understand your query, and sends that query, you know, syntax checking all of that, and sends that query to the query processor, right? So the second tier is is the one that will analyze the metadata into what would be the best plan to collect this data from the lake. You know, what would be the best way? So keep in mind, and let me pause in here, allow you to breathe. Keep in mind that we are talking about the data stored in the data lake. How is the data stored in the data lake? They're stored as files. So all the evaluations that SQL Server, Serverless SQL Pool will do here to collect the data is based on the file, on the file organization, how you organize your files in the data lake. So all those concepts about partitioning in the lake, they are very important here in Serverless SQL Pool because you don't manage the data from SQL Pool. The data is managed at the lake. And at this point, Serverless SQL Pool likes to work with two types of data files. CSV files, comma separated value files, and Parquet files. And the best option, of course, is Parquet due to compression and all the optimizations of the data stored in there. So bottom line, you do want to work with Parquet files when you are doing serverless SQL pools. So you can use CSV. I use CSV from time to time for smaller sets when you're doing some dimensions and things like that. For your fact tables, you know, for large data volumes, you do want to do Parquet. So when the DQP goes into creating a plan to collect your data, what it is looking into is how your query looks like if you're leveraging partitioning in the lake. Specifically, if you're doing Parquet, also looks into that, and then it creates a plan. Now, here's a disappointing information for you. That plan it creates under the hood, we can't see it, right? I'm a SQL guy. I've been working with SQL Server 6 since SQL Server 6.5, and every time I go into optimizing a query, what I do is I want to see the query plan. In Serverless SQL Pool, we don't have that, at least yet. We don't have that. We must understand how the lake is organized and how our query is working. and what we are tapping, and also how Parquet files work themselves, right? So it's a column of storage approach. So as you collect more columns, you are tapping into more data. So therefore, you're moving more data, right? So the columns you refer to on your projection and your outcome, they really impact the performance and, of course, the size of your results and the data volume you are collecting with. DQP looks into all of that. It goes into the files. It has, if you have created metadata about those files, it looks into those files and to try to create a plan. Statistics are available. DQP and Serverless SQL Pool is able to create statistics on data distribution on those files, both in CSV and Parquet files. So it's a cost-based execution plan, but we don't see that execution plan. When that plan is ready, what happens after that is it sends it over to see under the hood. Everything is SQL Server here. So it goes into SQL, start creating SQL Server nodes under the hood in order to create parallel processing to tap into the data into the lake. And according to the plan, whatever happens under the hood, it will create new nodes to process that data in parallel. So like I'm using 3-4 partitions and different files, so I can use different nodes to go into different files or collection of files and read those files in parallel and creating partial results. And when I finish with the partial results, I can funnel up that data to be stitched together all the way back to the end user. And depending on the amount of data and how it goes, you can create even more layers. These layers, this vertical layering of parallel SQL nodes running under the hood, is completely managed by the serverless. We have no say on any of this. The only way we have to somehow do some influence, kind of suggest what to do, is by doing well-organized data lake, partitioning data lake. So these parallel processes can be done on the lake. And when you get to a point where the serverless SQL pool understands that's the right sizing in the amount of SQL nodes to query the data, it goes into the lake on all the files that are involved into that one and process those files in, right? Get the data from those files, each node does its job on its own and moves the data up. So this is what happens under the hood, and it's completely oblivious to us. We don't have any control of that. You don't have to worry about anything of that. It's so much so that if one of these nodes fail, let's see if my laser point is working better now. Still very sluggish. But if one of these nodes here fail, look at it's way down there now. You have no idea how sluggish this thing is. All right, let me try the trackball. Yeah, Zoom is having a hard time with my computer today. In any case, imagine one of those nodes, if while processing the data in one of those SQL nodes, if it fails for some reason, the virtual machine under the hood process this thing breaks, that's a hardware failure, whatever it is. If something happens under the hood that makes one of these nodes fails, there is a tracking of that. Another node will take care of and rerun the failed process, and a new node can be spinned up even to get that one. So that will slow down the overall performance. So the performance is somewhat variant. It's not drastically variant. Like you run it once, it runs in 1 second. You run it again, it runs in 1 hour. It's not anything like that. But you may see some variances due to some circumstances there in the underlying process. So this is what you get into when you start using serverless SQL pools to support your queries into the lake. I've been, working with this. I've been implementing this to customers, and I've been getting great results. That's why I put this session together. So let's wrap up this session in the next 10 minutes or so you have with some demos here. So let me switch to my browser where I have a, let me zoom in here, where I have a Synapse workspace already created for us. So here's my Azure subscription. You see my email here, right? arlacerda@hotmail.com. Please do not email me on this on this account. I use that just for as my ID to get things with Microsoft, like this Azure subscription is one given by Microsoft for me to do this kind of demos. As an MVP, they do this kind of things for us to benefit you. So that's a great thing. Thank you, Microsoft, for the sponsorship. And here I created this resource group with the Synapse workspace already there. I won't bother you on creating the workspace itself. The process is super simple. There are some specific elements there you have to pay attention to. And if you want to learn more, you can join me or Wolfgang in our classes during the DPG pre or post conference events, right? Our 8-hour sessions there, or classes, I rather say. So here, when we go into the workspace, actually I'm not in the workspace yet. This is just the service in Synapse. And from here, you can see you can create a dedicated SQL pool and can create an Apache Spark SQL pool. But where is my serverless? Oh, that's the great thing about it. The serverless, I don't have to create, is already there. When I create a Synapse workspace, it's just there. It's already there. So if you go here into the SQL pools, I see that it's a serverless already in there. So I don't, it's so simple to use this thing that I don't even have to bother about creating the SQL pool. It's the serverless SQL pool. It's already there, created for me when I create the workspace. So if I click here on the Synapse Studios, where I have fun with everything inside Synapse, I have already clicked because sometimes the authentication fails. I have so many accounts from so many customers, sometimes this authentication fails. So I got the thing already created here and still in my account in here. So what you're seeing here, this is the workspace itself. Right now we are into the studio to work with the workspace. We have a navigation blade here on the left side where you can see a bunch of things. And here is your the data that's connected to your workspace. So as you can see, I have 0 databases. I do have a Synapse serverless. So if I go here into monitor, I will on the SQL pools, I will see here that I do have a serverless. There it is, right? And it's online. It's ready to go there. But I don't have any database. Funny thing is, even though the serverless SQL pool doesn't store data in itself, you are supposed to create a database to store the metadata about the lake. And if you're using the Spark inside Synapse, they exchange metadata. So when you create the table inside Spark, the Spark inside Synapse, the Spark pool, those tables are creating there and the elements are creating there, they exchange metadata with the serverless SQL pool. If you decide to use Databricks, it doesn't. So whatever you do in Databricks, you just create the files in there, and then you're gonna browse the files as I'm gonna show in here. But if you use the one that is in Synapse, they do exchange metadata, and therefore you should create a database in the serverless SQL pool just to store that metadata. So when I go here into the linked services, I see the data lake that I created. I created when I create the workspace, the Synapse workspace. And for this demo here, I copied over from a Microsoft repository. If you go in here, back to the Azure portal, if you go here into read the documentations, you can see some sample data in there. And also here from the workspace, if you click here, home, they do have some sample data here for you to get started with on the Learning Center here. So you do have some sample data here you can use to get started with. So what I did here for us for this demo is I copied over to the local data lake on my subscription, the New York Tax public database, right? The Microsoft already organized. It needs to do some ETL on these things. Here's already organized. So they have the yellow cab, the green cab, and just these two. I thought I had also the ride share. But let's take a look at the yellow. Again, this is the data lake. These are actual folders. If you use blob storage today, it's not folders yet. But that's just a suffix in there. There's not really, it looks like a folder, but it's not a folder. But here is a folder. And as you can see, we do have some partitioning strategy in here. So here I see that's based on year, and I will have months here. So let's pick any month. And for that month, yeah, year month, that's the how they organize the lake. I have my Parquet files. So, I just can just pick a Parquet file here, right click this guy and say, you know what, I would like to have a new SQL script because I'm Synapse, I have a SQL pool, so I can do a query on these files. And let's say I want to query, some rows out of these files. So as you can see, serverless SQL pools, it's really using internal resources in SQL. It's not using Polybase anymore, right? Because Polybase is an external process of SQL Server. Very, it's what you have when you do SQL Server on-premise. You do have open row sets also for on-premise, but you don't have parallelism when you do open row set. That's why you see so many SQL nodes going on, because you have SQL nodes as the parallel elements. Polybase will do that internally, right, within Polybase, but outside SQL, and gets the data ready and pushes it back into SQL. Here is already running into SQL and communicating between SQL. So we are dependent on open row set. We are leveraging open row set, which is super cool. So running this query here, and if you have seen any demo before, you probably have seen this query before, no big deal on this query here. Like I said, my system is kind of sluggish, so it's taking like long time to get this one here. I'm not sure if it's just my environment or is this the SQL pool warming up. So there you go. It took like 5 or 6 seconds before. Now it took 1 second, and it's going to be like that every time I run this because it warmed up already. Perfect. Great. And how much data did I tap when I run this? Remember, I'm charged by the data I move, right? My query moves. So when I click in here into the messages, I see a bunch of messages here about collation, character typing. And the thing about the character typing here in Synapse is that Parquet use that particular character typing there, and the default database collation, it's not that. So you got to see these warnings here all the time when you are working with serverless SQL pool, unless if you do data typing when you query the data. For open row sets, you can do with and defining data type, the actual data type for a column. So like in this one here, let's say we have a column here called, I don't see a string one. Let's move here around. Yeah, I don't see a string one. There is definitely one. I think this one should be string. So this column here, whatever this column is, I could go here and say, column 1 is a character or varchar, whatever it is. Varchar of some length collate, and then come in here with the right data type for that collate. In this case, UTF-8 something, and just put in there, and those warning messages they should go away. So if I go back here into the messages, let's get here to the messages. You see this particular query here worked with 24 megabytes from the sources and moved 1 megabyte up into the nodes to get you the final results. So this is how you measure, how much data you have moved, and this is how you're going to be charged. This is the actual information about data movement and how much you're going to be charged on for this particular query, which is this case here is cents of cents, fraction of a cent of a dollar. Just to get a feeling of how the partitioning here works, and also again, like I said, to wrap this up, my time is up, I think. What we're doing here is when we see this partitioning strategy was implemented in the lake for these Parquet files, we just do wildcards in here. So this is a year and this is a month, right? These are the 2 wildcards that I have. And I'm going to find multiple Parquet files in there. So therefore, I should have a wildcard for the Parquet file as well. So this will give Synapse Serverless SQL pool the perception of the partitioning. And if I want to check, or work with some partition elements in there, after defining the partition, I use a particular function called file path. So this is result, is the name of my data set in here, right? Result file. If I type it right, result file path, and the order of the wildcards, the place markers there. So the first one is number 1, okay, for the year. So year should be, let's pick here an year, like 2012. And this is regular SQL. So if I want to do 2 years, so I can do in, and keep in mind that these things are in the file system, so therefore everything is a string. So 2012, 2013. What's happening with me? I think I need more coffee. I can't type. 2012. And where? And because I'm not saying which month, it's going to work with all months, right? I'm just filtering on two particular years. So this will tell Serverless SQL Pool to create those nodes according to the partitions and the data volume on the statistics it comes to find this. So make this simple. We're going to do a count big for this guy just to see the processing that does particular just those 2 partitions. And again, if I look into the messages in here, you'll see that we should have worked with more data because I worked with more partitions, or just instead of just one file like before. And because I was just counting, there was not that many data going out, right? 0 data was written back because I didn't use any CTS. And of course, if I don't do any criterion here, I will work with the entire data set in there, and therefore the data volume would be larger. Query process would be a little longer here as well. And but I will have my result anyways, right? So there we go. I got my result in here. And I see I moved more data. I worked with more data because my partition, I did not leverage my partition, just do a full table scan, if you may, inside the entire data set. One last thing to wrap this up, if I go back here to the lake, that query is an ad hoc query, right? That you can just push that data in there. And if I want to query that data from Power BI, for instance, what I do here in Power BI is, I just say I want to get data. If you're here for the Wolfgang session, you saw Power BI inside the Synapse Studio, and I think I'm not going to be able to demo that. It's kind of running really slow here on my laptop. But again, if you're here for the Wolfgang session, you saw Power BI within the workspace. That's a great place to mock up some reports, but the point is, it's just one workspace in there. You cannot have multiple workspaces in there. If you just tap into Synapse, as you would tap SQL Server, so SQL Server database, for instance, as you would tap SQL Server, you can have as many users up there with all the Power BI subscriptions tap into the Synapse SQL Studio on their own environment. They don't have to jump into the workspace, and they will see the data there. I wish I had time to demo this here for you, but as you can see, my my workstation, I think I need to do a reboot or something. It always happens when I am doing these demos. So if I go back here to the browser and the workspace, and it says here serverless SQL Pool endpoint, I can copy this guy over from here. Here, and whatever data I bring, I want to import. I have to be careful with the data volume, right? But usually I want to do import, and let's go for that. So while I'm clicking around here, Emmett, is there any what other questions people have placed in there?
Yeah, Armando, we have a couple of questions.
Oh, okay, now I hear you.
Yeah, so first question is from Lekhan. From most of the diagram, SSA is not mentioned. Was it intentional, or we don't longer need OLAP for Power BI to consume? Most of my deployments uses SSAS to connect it to Power BI.
Right. SSIS is like the integration SQL Server Integration Service, right? And
Uh,
the thing is, SSIS is a transformation, like the pipeline is, and Databricks is a transformation resource that is intended for on-premise, right? It really doesn't scale at the cloud level. So Azure Data Factory supports SSIS in the cloud. You can run in there, but it's considered like a legacy support to keep your investments in SSIS, but new systems should not leverage SSIS.
so next question is from Hamilton. How is Parquet used?
In the same way, this session was about serverless SQL pool, right? But if you want to do a Spark pool, you go into the workspace. If we can browse back there, if you go to the workspace in here, and I'm glad I'm the last session, right, Emmett? So I can kind of stand here just a little bit, I hope. But yeah, if you go in here, you create a new Apache Spark pool. You can do from here, from the workspace itself. We create a new Apache Spark pool. And from the studio itself, you can come into the development and you can create notebooks working on top of the Apache clusters you just created, and you run your Scala script, Python scripts, C# scripts. You can run those from the notebooks. So that's how you do it for Spark.
So there is another question from Kulendra Singh. Will there be a performance slowdown in serverless SQL pool due to spin out of compute nodes in comparison dedicated SQL pool?
Can you repeat the question, please?
Yeah. Will there be a performance slowdown in serverless SQL pool due to spin out of compute nodes in comparison dedicated SQL pool?
So you cannot really compare both, because the dedicated is like, if you are in 500 DWs and you jump to 1000 DWs, they will spin up the new cluster for you, and then you're going to move around, right? You're going to jump around. So there is a moment when things got disconnected and back. In serverless SQL pool, that doesn't exist, because the parallel nodes running your queries are created dynamically and shut down dynamically when the query ends. So there is no memory in between queries besides whatever is stored in the lake. So you don't see the same behavior because you don't scale it up and down. Serverless SQL pool does it on its own. So there is really no comparison on that particular sense. You don't see any slowdown because every query works on its own collection of nodes created specifically for that query. Is a per query execution plan and node creation.
Okay. So there is another part of question. Can we do transformation using CTAS in SQL serverless pool and store back in Azure Data Lake?
Yes, CTAS is exactly for that.
Okay.
So if you come in here, let me see if I can bring an example here just quick. If we Google that super quick here, site docs.microsoft.com, Synapse. Did I type it right? Synapse CTAS. Should be at the top of the list here. Yeah, create external tables like that. So you can do a query. Let's jump straight into an example here. So you create an external table. This external table will land in the lake as a file there in the lake. If you have a data source created already, so it's a folder there in the lake, or you can use just a regular place with the partition, whatever you want to do. And the result of this select will be stored as, in this case here, it doesn't say, it seems to be like a Parquet file or something. Will be stored whatever format this thing refers to back into the lake. So this is how you do it. That's the answer for that question, right? This is how you do it. You do data transformation in your select to do any calculation you want to do. In this case here is doing an aggregation and writing back into the lake as a new table in the lake. A new Parquet file in the lake that can be referred to as a table.
Yeah. Another question from Madhu. Can I do multi-dimensional model in Azure Synapse? Example, dimension, facts, cubes, etc.
So MDX cubes that were first supported by SQL Server Analysis Service back 20 years ago, they are not seeing more investments from Microsoft. Microsoft is not putting more development into that technology. So we don't see that technology outside the on-premise or VMs in the cloud. What we have is tabular. And in terms of tabular storage, you have tabular support only in the dedicated SQL pool. We do see some similarities in between how tabular column store indexes work in the dedicated SQL pool and the Parquet file format. There are some similarities in between those. So in a very distance, safeguarding the platforms and the software houses, you can do tabular modes in serverless SQL pool when you do Parquet, but it's not the column store. On the other hand, this is all relational, right? So you do have effect tables, you do have your dimension tables, but on the multidimensional approach, which is pre-calculated aggregations, that it's not the way you would work in here. You don't have built-in support for that. You can create yours if you want and manage it on your own, but there is no built-in support in serverless SQL pool or any other platform besides the analysis service multidimensional mode.
Okay. Another question from Kulendra Singh. Which one will be better out of serverless and dedicated SQL pool for querying for operational purpose or from an application for end user consumption of data?
It all depends on the use case, right? Both have their place as a solution for a particular use case. What I've been doing a lot in my projects is leverage serverless SQL pool, like I said, to tap into the lake without having the extra step of importing the data into a dedicated storage or a specialized storage. So that has helped creating results super fast, right? There's no extra transformation to be applied, and better integration with other platforms. Like if I have a team that's already working Databricks or some other tool, that the connection and the streamlining of the process has been really good. Dedicated SQL pools is a great resource. I have been using dedicated SQL pools for over 5 years. In multiple scenarios. So do we have the use case for that? We should keep using that for the correct use case. But the serverless, especially when you're tapping data like in Power BI that I was trying to demo in here, but so slow here, I will not be able to get to that portion of the demo. It's, for data scientists and people exploring the lake, it's even super easier.